Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published just yesterday, which introduces a new method that achieves 3 times faster performance than Apple's Rosetta 2. The paper is titled Guaranteed Guess, a language modeling approach for CISC-to-RISC transpilation with testing guarantees. So the core idea here is tackling a really tricky problem: how to translate software between different chip architectures. Specifically, from what's called a complex instruction set computer, or CISC, like the x86 chips in many PCs, to a reduced instruction set computer, or RISC, like the ARM chips in our phones. This method uses an LLM for the translation and then rigorously tests it, and as we'll see, the results are quite impressive. Also, the authors shared their implementation on GitHub. If you check it out, you'll find everything needed to run inference with their pre-trained models. The repository is nicely structured with folders for the training and evaluation code, giving you a clear look at how they put it all together. On Hugging Face, you can download their transpilation models with weights from 630 million to 1.8 billion parameters, ready for you to try out for text generation. Alright, so this diagram gives us the full picture of their guaranteed guess system. On the left, you see how they create the training data. They take a huge amount of C and C++ code from datasets like StackV2 and EngaBench and compile it into paired examples, one for the complex instruction set computer architecture and another for the reduced instruction set computer architecture. Then, on the right, they use this data to train their specialized LLM. They also use a technique called rope extrapolation, which helps the model handle much longer code sequences. Finally, the translated code is rigorously tested to guarantee it's correct. Moving to the results, this table really drives home the effectiveness of their approach. It compares their guaranteed guess models against several standard coding LLMs, like GPT-4o and DeepSeek Coder, on various benchmarks. The columns also show two compiler optimization levels, O0, which is simple, and O2, which is highly optimized for speed, making the code much harder to translate. The key takeaway here is stark. Look at all those zeros. Most baseline models completely fail. In contrast, the guaranteed guess models achieve incredible accuracy, hitting over 99% on some tasks, which really shows the power of their specialized training. Building on that impressive accuracy, these charts show how guaranteed guess stacks up in the real world. They compare it against Apple's Rosetta 2 and native binaries, which is code compiled directly for the hardware. Looking at execution time, their method is nearly twice as fast as Rosetta 2. It's also more energy efficient. But the most striking result is the RAM usage. Rosetta 2 uses more than double the memory, while the code from Guaranteed Guess uses the exact same amount as the native version. This shows their approach is not just accurate, it's incredibly efficient. So, we've seen how efficient the final translation is, but what exactly makes it so accurate? Well, this ablation study breaks it down piece by piece. Starting with the base model, QN 2.5 coder, the accuracy is 0%. But look at this. Adding their specialized training data provides a massive 94% jump. After that, other tweaks like rope extrapolation, which helps the model handle longer code sequences, and 8-beam search, a method that explores multiple translation options, each add another crucial 1-2%, pushing the final ARM v8 accuracy to an amazing 99.39%. So, to wrap things up, what this all shows is that by combining a specialized LLM with a rigorous testing framework, Guaranteed Guess achieves what other models can't: highly accurate code translation between different processor architectures. Specifically from a complex instruction set computer architecture to a reduced instruction set computer architecture. This isn't just an academic exercise. The translated code runs significantly faster and uses far less memory and energy than current industry solutions. It's a very promising step towards a more flexible and efficient software ecosystem. That's all the time we have for today. Thanks for tuning in to the AI Research Roundup.